Hey there, Hux. So today we're going to talk about why nuclear reactions are so important. Um, and the reason why is because of the energy that's formed when they happen. And so Albert Einstein, back in the 1930s, beginning of the 1930s, he studied nuclear reactions or nuclear radiation. And he determined that those nuclear reactions produced a lot of energy. And it basically was based on the mass, right? The mass that's being ejected, or just the mass in general. That energy is given off. He felt that we could harness this energy, but it needs to be sustainable and controlled. And in order to actually use energy, you need to be able to sustain energy input, right, as well as control the reaction that it's coming from. So what he was working with was, like alpha and beta decay, and he found that naturally occurring decay, like alpha and beta, only occur randomly, and therefore it's not sustainable, because if you don't know when that decay is going to happen, you don't know that you need to capture the energy right after it does happen. So and the amount of time is just, minuscule. So we have to make sure that we're there. So that's not exactly a good way to do it. But in 1938, Otto Hahn, Lisa Meitner, and Fritz Strassmann found a more controlled reaction, and something that was more harnessable, for the energy, and it was called fission. And so what they found was, for atoms that have a 60 or higher um, nucleon number, so like their nuclear mass is 60 or higher, those atoms are easily split apart into two smaller atoms. Because remember, um, one of the reasons why the atoms are unstable is because they're too heavy, right? Remember, they're too heavy. The backpacks are too big. So, in they'll easily split into just two smaller atoms, just so that they can, not be as unstable. And again, when they do that, it gives off a lot of energy. And so that's called fission. And fission happens when a heavy nucleus, right, a heavy nuclei encounters energy, right? So that means that something has to hit it. In this case, it's a neutron. In most cases, it's a neutron. Okay. Um, and then splits to form two smaller, like medium sized nucleus. So in this case, I have uranium, and it's being hit by a neutron, and that neutron is adding enough energy so that it's now going to split apart. It becomes unstable and says, "Oh, I'm going to split this in half," or not quite in half. And from that comes a krypton atom and a um, barium atom. And these two are much more stable than the unstable uranium. This one also creates, in this case, two neutrons. Um, the picture shows three, but it can be two. But notice that the neutrons are ejected during this reaction, and so that means that those neutrons can fly off and hit other um, uranium atoms and cause those um, to also react. And so um, these are what's called chains. You end up with chain reactions. And if the chain reactions aren't controlled, so if the number of neutrons aren't controlled, all of a sudden you can get this huge explosion, this nuclear explosion, um, because you find that a huge number of atoms are all trying to split at the same time, and all of that energy goes out, and all of it goes out as an explosion. That's like the nuclear bomb kind of thing. Now, a better way to actually get um, energy is to fuse together two smaller atoms. So fusion happens when two small, really light atoms, light nuclei, combine to form one larger nuclei. So in our picture here, I have deuterium, which is a type of hydrogen, and tritium, which is another type of hydrogen. And they come together, right? They're knocked together, they collide, and they form a helium. Okay. And so all that energy is released, and there's a helium atom left. Um, and then there's a neutron that flies out. So that neutron can, fly out and possibly cause fission. But with fusion, that neutron's not going to make another fusion. So it's a lot more stable to try and create fusion energy than it is to do fission energy. And fusion energy, but why do we want to do fusion energy? Because fusion energy releases several times more the energy generated by fission. So it makes it way more powerful. And we know this because this is how the sun gives off its energy. The sun is made basically of helium and hydrogen, and the hydrogen atoms in the sun come together and they fuse together and they create helium, and you get this huge amount of energy off of it. And so this is how we know that fusion would actually be a better way of um, of getting this energy, of sustaining this energy. Um, we have not yet been able to create a sustainable fusion generator, but they are working on that. Okay, so you should now be able to tell the difference between fission, which is a large atom breaking apart, and fusion, where it's the smaller atoms coming together.